Hi, I'm Nick Vendegies, and we're here at the end of a very busy week at the Pete's Terrace and the iHub. We've moved all the sensors out. What we've been working on all week is that the sensors that were designed and built in the previous months were taken out to Nairobi, and we've been working on to try to build the link from these sensors, which are in different states of readiness, through a central heart, which is the Raspberry Pi, connecting to the internet, being projected into what we call the Intelligent Operations for Water, which is a large IBM-based operating system which will show the data. We're going to go very rapidly through the different sensors, then we say a little thing about the Raspberry Pi, and then we end up with a shot of the IDOW. Please go ahead.
I'm Lucky Pope, Kendi. I'm Lucky Pope, Kendi from Futa, Nigeria. We have built some sensors. We have radiation sensor, sunshine sensor, cyclometer to measure RH, input pressure, and dew points. Then we have a reinforcement sensor, and we call it tipping bucket. Then we have the evaporation sensor. Thank you.
My name is Ahmed Balogun. I'm from Federal University of Technology, Akure, representing Team Futa, Nigeria. Just like my colleague has said, he's also from Team Futa. We have a couple of sensors. He did mention a few of them, and including the anemometer, which you can see here. Thank you.
I am Hope Orobode from the Covenant University team in Ota, Nigeria. Here we designed two sensors. The first one is this, which will measure the direction of the wind, and we have another one which measures both the direction and the speed of the wind. We will measure the speed of the wind by the pressure of the wind acting on the diaphragm. Thank you.
I'm Otubu Ademola from Obafemi Awolowo University Electronic and Electrical Engineering Department. And here we built a temperature, the pressure, humidity, and dew point sensor all in one. So it measures all these weather variables and gives us the output. Thank you very much.
I am Okola Abdullah from Obafemi Awolowo University, a member of Team Impact from that school, and we have built a relative humidity sensor here, as you can see.
I'm Niyi Oke, also a member of Team Impact from OAU, Nigeria. And we designed this with our other teammates.
Oh, that's not a good idea. I'm Mukanda James from Zimbabwe, the University of Zimbabwe in Harare. I've been working on the electronic barometer, which uses magnetism as a transducer. So as you can see here, there is an anorak capsule which senses the movement and also changes changing the magnetic field to your voltage. Thank you.
My name is Gilbert Kamau from Kenya University, Jomo Kenyatta University of Science and of Agriculture and Technology. We have designed with pen, with direction, with speed, and with temperature sensor. And then we connect that to this gadget here, which displays it.
Kenneth Odhiambo, instrumentation and control engineer. Gilbert and I have designed the wind speed, temperature, and direction sensor. This is the brain of the system that will display the data and transmit it to the main controller, the Pi. Thank you.
I'm Irene Harim from UVM University. We make 3 different projects, but we are here to defend a soil humidity sensor. And it works with the top equation, and it measures, the soil moisture.
Adam Glee from Cambridge University. I'm here representing the Raspberry Pi Foundation. I've been working on integrating all the sensors created by the teams into the Raspberry Pi and then uploading it to IBM's Intelligent Operations Center. It's been a real pleasure working with everyone this week, I'd like to say congratulations to everyone. Look forward to seeing it all working.
Sarada George from Macquarie University, and I've been working on radiation sensor that uses transistors and photodiodes. This looks at incoming shortwave radiation and longwave radiation, then the outgoing longwave radiation.
So these were the sensors. They're all connected now through wires that you see here and there on the table to, and it's difficult to find, but here it is. This is sort of the brains of the moment. This is the Raspberry Pi. It's a full-fledged computer. It's extremely flexible. It runs Linux, and it costs about 30 euros. Here you can see a better shot, if you want, of a typical Raspberry Pi. Now this now connects to the internet and sends every minute all the data. It scans through all the sensors and sends all the data to the intelligence operations for water of IBM, which, as you can see, no wires attached, comes all the way, probably goes around the world 3 times before it comes back on Rolf's screen, who will explain it a little bit more.
Yeah, so all the sensors are given a location and a timestamp every time they do a measurement, and I have here a map of Nairobi where you can see the different sensors. So there's a wind speed sensor somewhat south of Wilson Airport, and there happens to be here on Long Road, where we are, 21 sensors that happen to be on this table right next to me. So you can see the IDs of all these sensors here, and if we scroll down a little bit, we can see that these sensors actually have recent values uploaded to this environment. This environment is pretty data heavy, so there's also a light version, which I have in this other tab, where I can just pick one of the sensors of one of the teams. So I could pick the air temperature sensor here and then ask for recent readings, which shows that it has been cooling down slightly, about 0.3 of a degree over the course of this presentation.
Thanks, I think it was a great week. I think maybe we can all cheer one time for TAHMO.
Yay! We did it! Woo!